Hello, welcome to my tutoring channel. This is my second geometry video and it's basically about some postulates and rules that we need to know. Last video was some basic definitions. This is the continuation of that. First off, I'm gonna have to introduce you to someone. His name is Euclid, and he was a famous Greek mathematician who revolutionized geometry. He wrote his own book called The Elements. I highly suggest you read that if you're interested in geometry because it's basically all of geometry in one nice book. I think there are like quite a few chapters or volumes, but all of it is very interesting. Anyway, back to this. Euclid opened his book with some postulates, 5 of them, that lay the groundwork for geometry. So I'm just going to go through some of those postulates. If you don't know what a postulate is, I explained in my last video, postulate is basically a rule that we take without proof. We take all 5 of these rules without proof. That's why they're postulates. Some of them are intuitive. So the first one especially, it's a straight line segment can be drawn joining any 2 points. So given a point like this and a point like this, you can connect them with a straight line segment. Also, these postulates contain some geometry terms, so if you're not familiar with them, I will be making a future video about some terms that are important, but right now the first unit in air quotes, by the way, because these are all separate topic videos. The first unit we'll be covering is just basics like statements, reasoning, proofs. So we won't be covering the terms for now. So if anything confuses you, feel free to search it up. For example, line segment is basically a portion of a line that has 2 endpoints. So basically, 2 points, you can draw a line segment through them. The second rule is any straight line segment can be extended indefinitely into a straight line. I should have probably kept that line segment, but anyway, I'll just draw a new one. So basically it's saying that this line segment can be extended into a line. The definition of a line is it continues infinitely in both directions, so this proves that point. Or more accurately, it uses that point to make this postulate. Given any straight line segment, a circle can be drawn having the segment as the radius and one endpoint as the center. So there's always going to be some circle in which the center is one of the endpoints and the radius is a given line segment. So I sort of did it the other way. I drew the circle first, but you can also say, now that I have like something like this, I can draw a circle that fits it. Of course, my circles are not that great. Let me see if I can fix it. Oh, God. Yep, this should be good. Yeah. So this basically illustrates my point that given a line segment, you can make a circle with a radius, the length of the segment, and one of its endpoints being the center. And the fourth postulate says that all right angles are congruent. So a right angle is basically an angle that measures exactly 90 degrees. And it's represented with a little square over here to show that it's 90 degrees. It's basically saying all angles that have 90 degrees have the same measure, which is sort of intuitive, but it's one of the basic principles of geometry. Fifth one. This is the most complicated one. It has its own name called the parallel postulate, and you'll see why in a moment. It goes like this. In a plane, given a line and a point not on it, there's exactly one line that passes through the point and never meets the first line. Lot to unpack there, so let me start. In a plane, so this board is just our plane for now, given a line and a point not on it. So let's draw the line. So I'm drawing a segment right now because it's not infinite, but let's assume it's a line. And a point not on it, so some points randomly like this. There's exactly one line that passes through the point and never meets the first line. So never meets the first line. That basically is the definition of parallel, which is why this is called a parallel postulate. There's only one line that is parallel to the line that goes through this point. So that would be this line right here. And again, it's a segment, but if I were to extend it on both sides, it would be parallel. It would be a line. So there's exactly one, and that's only true in Euclidean geometry. Yes, he has his own geometry. The non-Euclidean geometries have different postulates. There's like spherical geometry and so on. They are different. You can actually like have triangles that are curved and whatnot, but this geometry, unfortunately, will just be focusing on Euclidean geometry. Anyway, so those are Euclid's 5 postulates that he used in his book, The Elements. Now, the video's not over yet. There's one more thing I wanted to talk to you about today, and that's the second part, the rules part. And it's not actually rules like no running in school, it's more like construction rules. Basically, some stuff you want to follow if you want to do this thing called construction. And construction is basically when you use two tools, a straight edge and a compass. A straight edge is basically a ruler without the measurement marks. It's basically just a piece of metal that's straight, so you can draw lines. A compass helps you draw circles, and you basically using those two tools, you can do a bunch of stuff, and that's what constructions are. So construction rules, there's 5 of them. The first one is, given a point, we can draw the lines that pass through the point. So, given a point, we can draw all infinity lines. So these are line segments, like I said repeatedly. But we can draw all infinity of them. I can't draw all that because that'll take like an hour or even more. I mean, it's infinity, so it'll take all of time to do it. But anyway, I digress. The second one is, given 2 points, we can draw the line that passes through both points. So similar to the first Euclidean postulate, given 2 points, you can draw the line that passes through it. Okay, I know this doesn't pass through the second point. Let me just adjust it real quick. There. So given 2 points, you can draw the line that passes through both of them. Similar to Euclidean's first postulate. Given a point, we can draw the circle centered at that point. So, if I had a point like this, I can draw the circle like this, the circle like this, even this one, even one that goes off the board, but I can't really draw that. There are infinite of them, just like the lines that pass through a point. Okay, given a point and a segment, we can draw the circle centered at that point with the radius equal to the length of the segment. Again, this is similar to one of Euclid's postulates. If you want, you can pause now, go revisit your notes or a few minutes ago in this video and find out which of the postulate it repeats, but it's actually, if you want, you can pause. It's the third postulate. Given any straight line segment, a circle can be drawn having the segment as the radius and one endpoint as the center. It's basically the third postulate, but it's saying we can draw that using a compass and a straight edge. For example, if we were given this, and we were given any segment, basically, we can basically move that segment here and create a circle. Okay, this is going to be a really big circle. Let me adjust the size and the position. Yep, that looks something like it. And it crops over a title, so I'm going to have to erase it quickly. But basically what we can do with a compass and straight edge is absolutely marvelous. The last rule, we just went over the postulates a few minutes ago. The last rule is, given 2 points, we can draw the circle through one point with the other point at its center. So, given 2 points, again, this is going to be a pretty big circle. Let me see if I can first make a circle, then I'll adjust the position size. There, that should be good. Oops, too big. Okay, there. We can use one of the points as the center and the other point as a point in the circle to actually draw the circle. In both the fourth and the fifth postulates, there's only one circle that exists that fits the criteria. Oh, why do I keep on saying postulates? I mean, in the fourth and fifth rules, there's only one circle. But in the third rule, there's infinite circles. In the second rule, there's one line. In the first rule, there's infinite lines. So basically, it's like infinite, 1, 1. Basically, a bunch of stuff we can do with a compass and a straight edge. So that's that. Postulates and rules, some important stuff to know for geometry. So it's just setting the road. But after that, we're going to be looking at statements and reasoning. So thank you. See you next time.